Very good morning, class. In the previous video, we have done some introductive part of this chapter. We have understood what is motion, what is rest, what is frame of reference, and etc. In today's video, we have some topic that we have already done in the class 9th. That what you understand by displacement, velocity, instantaneous velocity, acceleration. So I'll not take so much time in this topic. Let's quickly revise all of these quantities, starting with the displacement. So when we say displacement, suppose we have 2 points. We have 2 point A and B. If any body covers the distance with the length between A and B and covered in a straight line or by the shortest path, then the length between the A and B is known as displacement, right? Or simply it is defined as the shortest length between 2 points. It is displacement, right? So it is shortest length of the path, right? It is vector quantity. We all know that because displacement have a specific direction and magnitude as well. The MKS unit is meter per, and the MKS unit is meter, and the CGS unit is centimeter, right? This is your displacement. Now what is distance? Distance is basically actual length of the path, right? Suppose a body started their journey from A and reached to B by taking this path, right? So the actual length, how much length we have covered, that is known as the distance, the actual length of the path. The actual length of the path. Here we are not taking any shortcut, right? This is your distance. Obviously distance is a scalar quantity because you can see here in this diagram it doesn't have any specific direction, because if you consider at this point the body is moving at this point, you can make tangent and you can check the direction of the body, right? Like you see here, at every point the direction of the body is changing. That is why distance have no specific direction. That's why it's a scalar quantity. So this is scalar quantity, and the unit is same as the displacement, that is meter and centimeter, right? This is your distance and displacement. Now let's talk about the velocity and speed. Velocity is basically displacement covered by the body in 1 second, right? According to the formula, velocity is equal to displacement upon time. So velocity is nothing but displacement covered by the body in certain time interval. So how do we define it? Velocity is defined as the displacement covered by the body in 1 second. So obviously if the value of time is 1 second, then the velocity will be equal to displacement, right? What is the SI unit? MKS unit is meter per second or centimeter per second. So if we take the MKS quantity, MKS unit with the unit will be meter per second, and in the CGS it will be centimeter per second. Similarly, what will be speed? So before we jump to the speed, there are some more we can say part of velocity. Let's understand them first. Instantaneous velocity. Velocity, as we done that, velocity is nothing but displacement upon time. Now, if a body covers a displacement between 2 points in very short interval of time, right? So if interval is very short, then we can write this instantaneous velocity as we can write as s2 minus s1 upon t2 minus t1, or simply del s upon del t, right? Now if del t is too small, it tends to 0, it's too small, right? That means that this displacement covered between 2 points, the time interval is very, very less. Then this velocity can be written as ds by dt. What is ds by dt here? Basically, ds by dt, it is nothing but differentiation of displacement with respect to time. Now, what is this displacement? I'll take some lecture on it. All right. So I'll make you understand how to calculate the differentiation of any quantity or the integration of any quantity. I'll make a video on it. All right. So just now for now you understand this. The velocity, incident velocity, will be ds by dt, right? Here d by dt is known as differentiation of the quantity with respect to time, right? So if we differentiate displacement with respect to time, we'll get velocity, right? Now, second, the very important part of the velocity is average velocity. So the average velocity, again, it's quite simple. We are doing this from the class 9. The total displacement upon total time. This is the formula for average velocity. So if you want to calculate the average velocity between 2 points, first calculate the total displacement and then divide it by time interval. If anybody returns to its initial position after covering some displacement, then the average velocity of the body is always 0. Because suppose I have started my journey from this point and I reach to this point and then return and again reach to the point where I have started my journey. That means the total displacement between the body will be 0 and hence the average velocity will be 0. Now let's talk about the speed. Displacement depends upon velocity. Similarly, speed depends upon distance. So speed is basically nothing but distance divided by time interval, right? In short, v equals to s upon t. The unit is same as the velocity here. It is meter per second or centimeter per second. What is the definition? Definition is distance covered by the body in unit interval of time, right? That would distance covered by the body in 1 second would be equals to the speed of the body, right? Again, what will be instantaneous speed? That will be v equal to ds upon dt. The differentiation of the distance with respect to time will get the value of instantaneous speed. And what will be average speed? That will be total distance upon time interval. So this is the basic of speed and velocity. Now let's talk about the acceleration. Acceleration is basically it is a rate of change of velocity. Right? So A is basically V2 minus V1 divided by T2 minus T1, right? Or we can write it as del V upon del T. Rate of change of velocity. If del T tends to 0, again the time interval between the change of velocity is too small, then A, that is the instantaneous acceleration, can be defined as differentiation of velocity with respect to time. That means A will be equals to dv by dt, right? So you have done all these things in the class 9. That is why I'll not take so much time on it. You can read these 4 topics from your book, and if you find any difficulty, you can ask me. Now let's quickly revise the graphical representations of the velocity time, displacement time, and acceleration time. And before we revise them, let's quickly revise one more concept, that how do we calculate let's say velocity from displacement time graph or acceleration from velocity time graph. Then after I will cover the graphical part. So if we make a table, let's say where one column is for graph. How many graph we have? First we have the displacement time graph, right? Second we have velocity time graph, and third we had the acceleration time graph, right? Now we have to calculate some quantities. First, let's say I want to calculate the displacement or velocity or acceleration. We have to calculate these quantities with the help of these graphs. Now, when we talk about the displacement time graph, obviously to find the displacement from a displacement time graph, we can just directly read the graph and find the value. So we don't have any problem to find a displacement. Now, if we want to find the velocity from the displacement time graph, what we do, we find the slope of the graph, right? So in order to calculate the velocity from the displacement time graph, what we calculate the slope of the graph, right? To find the acceleration, we can't find the acceleration from the displacement time graph, so we leave it blank here. Although we can calculate displacement, we can calculate the acceleration from displacement time graph if first we have to convert the displacement time graph into the velocity time graph, and if we find the slope of the VT graph, then we can find the acceleration. But directly from the displacement time graph, we can't find the value of acceleration. Now, velocity time graph. In order to calculate the displacement from the VT graph, what we do, we find area under the graph, right? So there might be some shape. It might be rectangular, triangular, or it can be any shape, right? Parallelogram. So what we have to do, we just find the area under the graph to find the displacement. Velocity, again, you can directly read from the graph the value of velocity, and acceleration we find slope of the graph. Right. Now, acceleration time graph. We can't find the displacement from the acceleration time graph, but yeah, we can find the velocity, that is area under the graph. And obviously, in order to find the acceleration from the acceleration time graph, we can just read the graph and find the value of acceleration. So this table is very important in order to calculate these quantity with the help of graphs, right? Suppose you know how to deal with the graph, but you don't know how to calculate these quantities, right? So by this table, it becomes very easy to find quantities like displacement, velocity, and acceleration. In the next video, I will cover some important graphical representation like displacement time graph, velocity time graph, and the acceleration time graph, and their different cases. Till then, thank you so much.